Okay, my students asked for a video on how to do dihybrid Punnett squares because they're a little bit harder than the standard Punnett squares. I always use the Instructional Fair Reproducibles books. So I have the worksheet from this book, which is up on the board here. Okay, instead of having one allele that you're going to be crossing, you have two alleles. Which we get from the genotypes of the father and the mother. This one says that the mother has blonde hair and blue eyes. She's recessive for both traits. Lowercase b, lowercase b, lowercase e, lowercase e. The only two-letter combination that you're going to get from the mother is lowercase b, lowercase e. The only traits that she has to pass on are blonde hair and blue eyes. The father, though, is heterozygous for black hair and brown eyes. So that means that his children could have black hair or blonde hair, depending on who he's having children with, brown eyes or blue eyes. So there's four possible combinations from the father. We have capital B, capital E, capital B, lowercase e. Then we have lowercase b, capital E, and lowercase b, lowercase e. So what you're basically doing, it's almost like FOIL. You're using all four possible combinations of those letters that we're crossing here. And then you do the cross. In the smaller Punnett squares, you end up with just a total of 2 letters per box. Here we're going to end up with 4 letters per box. We have 2 traits we're looking at, the hair and the eye color. So this first one we have capital B, lowercase b, capital E, lowercase e. Here we have capital B, lowercase b, lowercase e, lowercase e. So here, the father has brown eyes, but because the mother has blue eyes and he carries the recessive trait for that, this child is going to have blue eyes, for example. Okay, so there's the first row there, and when I did this in class, my students were quick to point out, oh wait a minute, all of these 4 rows are going to be the same because the mother only has these letters to contribute. So all of these are going to be the same. I'll fill those in quickly so we can look at the question that it asked us to answer here. Okay, now it's asking what percentage have blonde hair and blue eyes. Okay, I suggested to my students, when you're looking at this huge mess of letters here, you can use a highlighter, you can underline, you can circle, something like that. So, who can tell me how many blonde hair and blue eyes I have out of these 16 squares?
4, 5.
There are 4. There's 1, 2, 3, 4. Okay. So there's a few ways to do this because some kids are not good with percentages, even simple math like this. 4 out of 16 equals 1/4. I told the kids 1/4 is 25 cents, right? 25%. Or you can just divide out on your calculator, 4 divided by 16 or 1 divided by 4. So 25% of the children will have blonde hair and blue eyes. Okay. Then when we go to this other cross here, it says both parents will have heterozygous black hair and heterozygous brown eyes. That means that the 2 letters do not match. Homozygous are when the 2 letters match. Okay. So now this is, in other words, both parents are going to be represented this way. That's both parents. put that down for both parents. Okay, and the results are different for this one. Okay, now where these were all the same in each row, these are not all the same in each row. You have a lot of different combinations here. So the genotype of the father and the mother, we crossed two people who were heterozygous for black hair and heterozygous for brown eyes. Okay, and now we've got very different results. Now, how many children will have blonde hair and blue eyes?
One.
Just one. Okay, and that's not 1%, that's 1 out of 16. So if you go on your calculator, 1 divided by 16, 6.25%. So there's two good examples of dihybrid Punnett squares.